Hello everyone. Today I will talk about my research paper, single-side hybrid selection coils from field-free-line magnetic particle image. My full name is Ying Wenfu. My ID 17146309. Instructor is Associate Prof. Trần Ngọc Tráng. Now let's go.
Chị này cái táo một gì ở đây chị chết được sao.
This research paper includes 6 parts: 1. Abstract, 2. Introduction, 3. Theory and methods, 4. Simulation research, 5. Discussion, 6. Conclusion. Now let's go. 1. Abstract, single-sided magnetic particle imaging (MPI) is a promising new development that can help translating MPI technology into clinical practice. We proposed a design of a field-free line selection field generated for the single-sided geometry. We extend our single-sided design to incorporate and more efficient scheme that utilize panel gate magnet. 2 is introduction. Magnetic particle imaging API is a promising imaging modality that has potential to outperform other imaging technology. The present simulation theory shows that such a device can yield from multi-dimensional imaging encoding while cutting down the power consumption and relaxing cooling requirements. 3. Theory and methods. 3.1 FFL generator magnetic design. A schematic diagram of single-side hybrid selection coils for FFL MPI. The FFL is generated by 4 permanent magnets along the y-axis above the coils. The blocks are arranged into inner and outer pair with the magnetic resonance magnitudes M1 and M respectively. Static selection magnetic fields along the z-axis as is equal 0 generated by the inner green dash, the outer blue dotted line set of magnets and their superposition red thin line A. First plot of the total magnetic field in the x-y-z plane showing a formation of an FFL. The FFL is generated along y-axis as that for has equal 8 to 8 FFM. The FFM flow x z axis hybrid driver selection coil designed for image. The piezoelectric magnetic field from the outer electromagnetic coils to and fro with hour of phase. Mutual current pattern shift the FFL in the XYZ plane. These coils can be used as jet driver coil, matched cousin, Z fellow T equal Z0 sin 2PF ZT, where Z0 is the current amplitude that defines the depth including Fz equal 10 to 25 kHz is the driver frequency. The response of the selection coil based on pattern magnetic can in principle be used with mechanical motion in the simulation fashion to or in compare with the external device field coils. Here we present an all-in-one aspect of the coil that are self-sufficient for 3D image encoding. For 3D image encoding, a second pair of coils is required to display the FFM along the x-axis. In our modern design, the X-driver pair of coils 1 and 3 are placed on the top. Z-driver coils as shown in Figure 1. The two X coils are driven with the inverse mutual AC current axis. Flow T equal I X0 sin 2 PF axis flow T, where X0 is the current amplitude that defines delta X encoding Fx equal 10 to 25 kHz in the driver frequency. The design of the selection coil based on permanent magnet can in principle be used to with mechanical motion in a simulated fashion to or in combination with the internal driver field coil. Here we present an all-in-one collection of the coils that are style substrate for 3D image encoding. For simulation and results, we carry out quality simulation using waveform maxi, our software with Radian package ESLF France. Our plot of principal simulation model we choose on 4 magnetic with equal dimension length with substantive fly of the selection coil made out of 4 payment magnetic with the FFL generated at Z equal 10 million above the surface. Simulated magnetic field B contour plot in the XZ plane and the YZ plane. Flow X plane, flow Z plane. Circuit fly of selection coils made out of 4 panels magnetic with the FFL generated as just 10 equal millimeters above the surface. B-field magnetic plots along the z-axis at x equals 0 and the x-axis at z 10 millis. The top sets of the coin tonight as 1 and 3 are used as X-driver coin and bottom pair 2 and 5 are used as yes-driver coins. X-axis encoding in the XY plane, the top-down magnetic field contour plot with the FM at X length 8 meters for X length equal 200 ampere, X equal 0 milli for IX velocity 0. Recently solved FFS spam for tangent X equal 16 milli bottom round XY plane contour plot style line FFM transistor X with constant yes 10 million as solved by rest dashed line. The contour line separations are injected for each plot in the bottom round. Figure shows the simulation result from the operation theoretical in combination with Synchronous. The above simulation shows example of XI Z-plane FOV encoding of 16.7 meters that can be linearly upscaled with corresponding higher peak current. The planned simulation of the modern selection driver system consisting of hybrid calls for feasibility for 3D image frame impacted the particle dimension and choice of the method strengths and the driver peak current have defined by the Cepheid application rather than made universal. Thank you for listening. My full name is Nguyễn Phu, and introduction is Associate Prof. Trần Ngọc Đạm. Do you have any question for me? Thank you.